Hi, today we are going to study about Earth. Earth is the third planet from the Sun and the only astronomical object known to harbor life. While large volumes of water can be found throughout the solar system, only Earth sustains liquid surface water. About 71% of Earth's surface is made up of the ocean, dwarfing Earth's polar ice, lakes, and rivers. The remaining 29% of Earth's surface is land, consisting of continents and islands. Earth's surface layer is formed of several slowly moving tectonic plates, interacting to produce mountain ranges, volcanoes, and earthquakes. Earth's liquid outer core generates the magnetic field that shapes Earth's magnetosphere, deflecting destructive solar winds. Earth's atmosphere consists mostly of nitrogen and oxygen. More solar energy is received by tropical regions than polar regions and is redistributed by atmospheric and ocean circulation. Water vapor is widely present in the atmosphere and forms clouds that cover most of the planet. Greenhouse gases in the atmosphere like carbon dioxide, CO2, trap a part of the energy from the sun close to the surface. A region's climate is governed by latitude, but also by elevation and proximity to moderating oceans. Severe weather, such as tropical cyclones, thunderstorms, and heat waves, occurs in most areas and greatly impacts life. Earth is an ellipsoid with a circumference of about 40,000 kilometers. It is the densest planet in the solar system. Of the 4 rocky planets, it is the largest and most massive. Earth is about 8 light minutes away from the Sun and orbits it, taking a year, about 365.25 days, to complete one revolution. Earth rotates around its own axis in slightly less than a day, in about 23 hours and 56 minutes. Earth's axis of rotation is tilted with respect to the perpendicular to its orbital plane around the Sun, producing seasons. Earth is orbited by one permanent natural satellite, the Moon, which orbits Earth at 380,000 kilometers, 1.3 light seconds, and is roughly a quarter as wide as Earth. The Moon always faces the Earth with the same side through tidal locking and causes tides, stabilizes Earth's axis, and gradually slows its rotation. Earth formed over 4.5 billion years ago. During the first billion years of Earth's history, the ocean formed and then life developed within it. Life spread globally and began to affect Earth's atmosphere and surface, leading to Earth's great oxidation event 2 billion years ago. Humans emerged 300,000 years ago, and have reached a population of almost 8 billion today. Humans depend on Earth's biosphere and natural resources for their survival, but have increasingly impacted Earth's environment. Today, humanity's impact on Earth's climate, soils, waters, and ecosystems is unsustainable, threatening people's lives and causing widespread extinction of other life. The shape of Earth is nearly spherical. There is a small flattening at the poles and bulging around the equator due to Earth's rotation. 85. Therefore, a better approximation of Earth's shape is an oblate spheroid, whose equatorial diameter is 43 kilometers, 27 miles, larger than the pole-to-pole diameter. The average diameter of the reference spheroid is 12,742 kilometers, 7,918 miles. Local topography deviates from this idealized spheroid, although on a global scale these deviations are small compared to Earth's radius. The maximum deviation of only 0.17% is at the Mariana Trench, 10,925 meters, or 35,843 feet below local sea level, whereas Mount Everest, 8,848 meters, or 29,029 feet above local sea level, represents a deviation of 0.14%. The point on the surface farthest from Earth's center of mass is the summit of the equatorial Chimborazo volcano in Ecuador, 6,384.4 kilometers, or 3,967.1 miles. In geodesy, the exact shape that Earth's oceans would adopt in the absence of land and perturbations such as tides and winds is called the geoid. More precisely, the geoid is the surface of gravitational equipotential at mean sea level, MSL. Ocean surface topography are water deviations from MSL, analogous to land topography. Earth's mass is approximately 5.97 times 1,024 kilograms, 5,970 e. It is composed mostly of iron, 32.1%, oxygen, 30.1%, silicon 15.1%, magnesium 13.9%, sulfur 2.9%, nickel 1.8%, calcium 1.5%, and aluminum 1.4%, with the remaining 1.2% consisting of trace amounts of other elements. Due to mass segregation, the core region is estimated to be primarily composed of iron 88.8%, with smaller amounts of nickel 5.8%, sulfur 4.5%, and less than 1% trace elements. The most common rock constituents of the crust are nearly all oxides. Chlorine, sulfur, and fluorine are the important exceptions to this, and their total amount in any rock is usually much less than 1%. Over 99% of the crust is composed of 11 oxides, principally silica, alumina, iron oxides, lime, magnesia, potash, and soda. The major heat-producing isotopes within Earth are potassium-40, uranium-238, and thorium-232. 103. At the center, the temperature may be up to 6,000 degrees Celsius, 10,830 degrees Fahrenheit, 104, and the pressure could reach 360 pa, 52 million psi. Because much of the heat is provided by radioactive decay, scientists postulate that early in Earth's history, before isotopes with short half-lives were depleted, Earth's heat production was much higher. At approximately 3 gyr, twice the present-day heat would have been produced, increasing the rates of mantle convection and plate tectonics, and allowing the production of uncommon igneous rocks such as comadites that are rarely formed today. The mean heat loss from Earth is 87 MWm2, for a global heat loss of 4.42 times 1013 W. A portion of the core's thermal energy is transported toward the crust by mantle plumes, a form of convection consisting of upwellings of higher temperature rock. These plumes can produce hotspots and flood basalts. More of the heat in Earth is lost through plate tectonics, by mantle upwelling associated with mid-ocean ridges. The final major mode of heat loss is through conduction through the lithosphere, the majority of which occurs under the oceans, because the crust there is much thinner than that of the continents. The total surface area of Earth is about 510 million square kilometers, 197 million square miles. Of this, 70.8%, or 361.13 million square kilometers, 139.43 million square miles, is below sea level and covered by ocean water. Below the ocean's surface are much of the continental shelf, mountains, volcanoes, oceanic trenches, submarine canyons, oceanic plateaus, abyssal plains, and a globe-spanning mid-ocean ridge system. The remaining 29.2%, or 148.94 million square kilometers, 57.51 million square miles, not covered by water, has terrain that varies greatly from place to place and consists of mountains, deserts, plains, plateaus, and other landforms. The elevation of the land surface varies from the low point of -418 meters, 1,371 feet at the Dead Sea, to a maximum altitude of 8,848 meters, 29,029 feet at the top of Mount Everest. The mean height of land above sea level is about 797 meters, 2,615 feet. The continental crust consists of lower density material such as the igneous rocks granite and andesite. Less common is basalt, a denser volcanic rock that is the primary constituent of the ocean floors. Sedimentary rock is formed from the accumulation of sediment that becomes buried and compacted together. Nearly 75% of the continental surfaces are covered by sedimentary rocks, although they form about 5% of the crust. The third form of rock material found on Earth is metamorphic rock, which is created from the transformation of pre-existing rock types through high pressures, high temperatures, or both. The most abundant silicate minerals on Earth's surface include quartz, feldspar, amphibole, mica, pyroxene, and olivine. Common carbonate minerals include calcite, found in limestone, and dolomite. Erosion and tectonics, volcanic eruptions, flooding, weathering, glaciation, the growth of coral reefs, and meteorite impacts are among the processes that constantly reshape Earth's surface over geological time. The pedosphere is the outermost layer of Earth's continental surface and is composed of soil and subject to soil formation processes. The total arable land is 10.9% of the land surface, with 1.3% being permanent cropland. Close to 40% of Earth's land surface is used for agriculture, or an estimated 16.7 million square kilometers, 6.4 million square miles of cropland and 33.5 million square kilometers, 12.9 million square miles of pastoral land. The gravity of Earth is the acceleration that is imparted to objects due to the distribution of mass within Earth. Near Earth's surface, gravitational acceleration is approximately 9.8 meters/s2, 32 feet/s2. Local differences in topography, geology, and deeper tectonic structure cause local and broad regional differences in Earth's gravitational field, known as gravity anomalies. The main part of Earth's magnetic field is generated in the core, the site of a dynamo process that converts the kinetic energy of thermally and compositionally driven convection into electrical and magnetic field energy. The field extends outwards from the core, through the mantle, and up to Earth's surface, where it is, approximately, a dipole. The poles of the dipole are located close to Earth's geographic poles. At the equator of the magnetic field strength at the surface is 3.05 times 10⁵ with a magnetic dipole moment of 7.79 times 1022 m2 at epoch 2000, decreasing nearly 6% per century. The convection movements in the core are chaotic. The magnetic poles drift and periodical. Earth's rotation period relative to the Sun, its mean solar day, is 86,400 seconds of mean solar time, 86,400.0025 c-seconds. Because Earth's solar day is now slightly longer than it was during the 19th century due to tidal deceleration, each day varies between 0 and 2 minutes longer than the mean solar day. Earth's rotation period relative to the fixed stars, called its stellar day by the International Earth Rotation and Reference System Service, EARS, is 86,164.0989 seconds of mean solar time, UT1, or 23h56 meters, 4.0989 seconds. Earth's rotation period relative to the precessing or moving mean March equinox, when the Sun is at 90 degrees on the equator, is 86,164.0905 seconds of mean solar time, UT1, 23h56 meters, 4.0905 seconds. Thus the sidereal day is shorter than the stellar day by about 8.4 ms. Apart from meteors within the atmosphere and low-orbiting satellites, the main apparent motion of celestial bodies in Earth's sky is to the west at a rate of 15 degrees divided by h equals 15/minutes for bodies near the celestial equator. This is equivalent to an apparent diameter of the Sun or the Moon every 2 minutes. From Earth's surface, the apparent sizes of the Sun and the Moon are approximately the same. Earth orbits the Sun at an average distance of about 150 million kilometers, 93 million mi, every 365.2564 mean solar days, or one sidereal year. This gives an apparent movement of the Sun eastward with respect to the stars at a rate of about 1 degree/day, which is one apparent Sun or Moon diameter every 12 hours. Due to this motion, on average it takes 24 hours, a solar day, for Earth to complete a full rotation about its axis so that the Sun returns to the meridian. The orbital speed of Earth averages about 29.78 km/s, 107,200 km per hour, 66,600 miles per hour, which is fast enough to travel a distance equal to Earth's diameter, about 12,742 kilometers, 7,918 miles, in 7 minutes, and the distance to the Moon, 384,000 kilometers, 239,000 miles, in about 3.5 hours. The Moon and Earth orbit the common barycenter every 27.32 days relative to the background stars. When combined with the Earth-Moon system's common orbit around the Sun, the period of the synodic month, from new moon to new moon, is 29.53 days. Viewed from the celestial North Pole, the motion of Earth, the Moon, and their axial rotations are all counterclockwise. Viewed from a vantage point above the Sun and Earth's North Poles, Earth orbits in a counterclockwise direction about the Sun. The orbital and axial planes are not precisely aligned. Earth's axis is tilted some 23.44 degrees from the perpendicular to the Earth-Sun plane, the ecliptic, and the Earth-Moon plane is tilted up to plus minus 5.1 degrees against the Earth-Sun plane. Without this tilt, there would be an eclipse every 2 weeks, alternating between lunar eclipses and solar eclipses. The Hale sphere, or the sphere of gravitational influence, of Earth is about 1.5 million kilometers, 930,000 miles, in radius. This is the maximum distance at which Earth's gravitational influence is stronger than the more distant Sun and planets. Objects must orbit Earth within this radius, or they can become unbound by the gravitational perturbation of the Sun. Earth, along with the Solar System, is situated in the Milky Way and orbits about 28,000 light-years from its center. It is about 20 light-years above the galactic plane in the Orion Arm. Earth's hydrosphere consists chiefly of the oceans, but technically includes all water surfaces in the world, including inland seas, lakes, rivers, and underground waters down to a depth of 2,000 meters, 6,600 feet. The mass of the oceans is approximately 1.35 times 1,018 metric tons, or about 1/4,400 of Earth's total mass. The oceans cover an area of 361.8 million square kilometers, 139.7 million square miles, with a mean depth of 3,682 meters, 12,080 feet, resulting in an estimated volume of 1.332 billion kilometers, 320 million cm. If all of Earth's crustal surface were at the same elevation as a smooth sphere, the depth of the resulting world ocean would be 2.7 to 2.8 kilometers, 1.68 to 1.74 miles. About 97.5% of the water is saline. The remaining 2.5% is fresh water. Most fresh water, about 68.7%, is present as ice in ice caps and glaciers. In Earth's coldest regions, snow survives over the summer and changes into ice. This accumulated snow and ice eventually forms into glaciers, bodies of ice that flow under the influence of their own gravity. Alpine glaciers form in mountainous areas, whereas vast ice sheets form over land in polar regions. The flow of glaciers erodes the surface, changing it dramatically, with the formation of U-shaped valleys and other landforms. Sea ice in the Arctic covers an area about as big as the United States, although it is quickly retreating as a consequence of climate change. The average salinity of Earth's oceans is about 35 grams of salt per kilogram of seawater, 3.5% salt. Most of this salt was released from volcanic activity or extracted from cool igneous rocks. The oceans are also a reservoir of dissolved atmospheric gases, which are essential for the survival of many aquatic life forms. Seawater has an important influence on the world's climate, with the oceans acting as a large heat reservoir. Shifts in the oceanic temperature distribution can cause significant weather shifts, such as the El Niño Southern Oscillation. The abundance of water on Earth's surface is a unique feature that distinguishes it from other planets in the solar system. Solar system planets with considerable atmospheres do partly host atmospheric water vapor, but they lack surface conditions for stable surface water. Despite some moons showing signs of large reservoirs of extraterrestrial liquid water, with possibly even more volume than Earth's ocean, all of them are large bodies of water under a kilometers-thick frozen surface layer. The atmospheric pressure at Earth's sea level averages 101.325 kp, 14.696 psi, with a scale height of about 8.5 kilometers, 5.3 miles. A dry atmosphere is composed of 78.084% nitrogen, 20.946% oxygen, 0.934% argon, and trace amounts of carbon dioxide and other gaseous molecules. Water vapor content varies between 0.01% and 4% but averages about 1%. The height of the troposphere varies with latitude, ranging between 8 kilometers, 5 miles at the poles to 17 kilometers, 11 miles at the equator, with some variation resulting from weather and seasonal factors. Earth's biosphere has significantly altered its atmosphere. Oxygenic photosynthesis evolved 2.7 Ga, forming the primarily nitrogen-oxygen atmosphere of today. This change enabled the proliferation of aerobic organisms and, indirectly, the formation of the ozone layer due to the subsequent conversion of atmospheric O2 into O3. The ozone layer blocks ultraviolet solar radiation, permitting life on land. Other atmospheric functions important to life include transporting water vapor, providing useful gases, causing small meteors to burn up before they strike the surface, and moderating temperature. This last phenomenon is known as the greenhouse effect. Trace molecules within the atmosphere serve to capture thermal energy emitted from the ground, thereby raising the average temperature. Water vapor, carbon dioxide, methane, nitrous oxide, and ozone are the primary greenhouse gases in the atmosphere. Without this heat retention effect, the average surface temperature would be minus 18 degrees Celsius, 0 degrees Fahrenheit, in contrast to the current plus 15 degrees Celsius, 59 degrees Fahrenheit, and life on Earth probably would not exist in its current form. Earth's atmosphere has no definite boundary, gradually becoming thinner and fading into outer space. 3/4 of the atmosphere's mass is contained within the first 11 kilometers, 6.8 miles, of the surface. This lowest layer is called the troposphere. Energy from the sun heats this layer, and the surface below, causing expansion of the air. This lower density air then rises and is replaced by cooler, higher density air. The result is atmospheric circulation that drives the weather and climate through redistribution of thermal energy. The primary atmospheric circulation bands consist of the trade winds in the equatorial region below 30 degrees latitude and the westerlies in the mid-latitudes between 30 degrees and 60 degrees. Ocean heat content and currents are also important factors in determining climate, particularly the thermohaline circulation that distributes thermal energy from the equatorial oceans to the polar regions. Earth receives 1361 W/square meters of solar irradiance. The amount of solar energy that reaches the Earth's surface decreases with increasing latitude. At higher latitudes, the sunlight reaches the surface at lower angles, and it must pass through thicker columns of the atmosphere. As a result, the mean annual air temperature at sea level decreases by about 0.4 degrees Celsius, 0.7 degrees Fahrenheit, per degree of latitude from the equator. Earth's surface can be subdivided into specific latitudinal belts of approximately homogeneous climate. Ranging from the equator to the polar regions, these are the tropical or equatorial, subtropical, temperate and polar climates. Further factors that affect a location's climates are its proximity to oceans, the oceanic and atmospheric circulation, and topology. Places close to oceans typically have colder summers and warmer winters, due to the fact that oceans can't store large amounts of heat. The wind transports the cold or the heat of the ocean to the land. Atmospheric circulation also plays an important role. San Francisco and Washington, D.C. are both coastal cities at about the same latitude. San Francisco's climate is significantly more moderate as the prevailing wind direction is from sea to land. Finally, temperatures decrease with height, causing mountainous areas to be colder than low-lying areas. Water vapor generated through surface evaporation is transported by circulatory patterns in the atmosphere. When atmospheric conditions permit an uplift of warm, humid air, this water condenses and falls to the surface as precipitation. Most of the water is then transported to lower elevations by river systems and usually returned to the oceans or deposited into lakes. This water cycle is a vital mechanism for supporting life on land and is a primary factor in the erosion of surface features over geological periods. Precipitation patterns vary widely, ranging from several meters of water per year to less than a millimeter. Atmospheric circulation, topographic features, and temperature differences determine the average precipitation that falls in each region. The commonly used Köppen climate classification system has 5 broad groups: humid tropics, arid, humid middle latitudes, continental and cold polar, which are further divided into more specific subtypes. The Köppen system rates regions based on observed temperature and precipitation. Surface air temperature can rise to around 55 degrees Celsius, 131 degrees Fahrenheit, in hot deserts, such as Death Valley, and can fall as low as minus 89 degrees Celsius, 128 degrees Fahrenheit, in Antarctica. A planet's life forms inhabit ecosystems, whose total forms the biosphere. The biosphere is divided into a number of biomes, inhabited by broadly similar plants and animals. On land, biomes are separated primarily by differences in latitude, height above sea level, and humidity. Terrestrial biomes lying within the Arctic or Antarctic circles, at high altitudes or in extremely arid areas, are relatively barren of plant and animal life. Species diversity reaches a peak in humid lowlands at equatorial latitudes. Estimates of the number of species on Earth today vary. Most species have not been described. Over 99% of all species that ever lived on Earth are extinct. A planet that can sustain life is termed habitable, even if life did not originate there. The distance of Earth from the Sun, as well as its orbital eccentricity, rate of rotation, axial tilt, geological history, sustaining atmosphere, and magnetic field all contribute to the current climatic conditions at the surface. Earth provides liquid water, an environment where complex organic molecules can assemble and interact, and sufficient energy to sustain metabolism. Plants can take up nutrients from the atmosphere, soils, and water. These nutrients are constantly recycled between different species. Extreme weather, such as tropical cyclones, including hurricanes and typhoons, occurs over most of Earth's surface and has a large impact on life in those areas. From 1980 to 2000, these events caused an average of 11,800 human deaths per year. Many places are subject to earthquakes, landslides, tsunamis, volcanic eruptions, tornadoes, blizzards, floods, droughts, wildfires, and other calamities and disasters. Human impact is felt in many areas due to pollution of the air and water, acid rain, loss of vegetation, overgrazing, deforestation, desertification, loss of wildlife, species extinction, soil degradation, soil depletion, and erosion. Human activities release greenhouse gases into the atmosphere, which cause global warming. This is driving changes such as the melting of glaciers and ice sheets, a global rise in average sea levels, increased risk of drought and wildfires, and migration of species to colder areas. Earth's human population passed 7 billion in the early 2010s, and is projected to peak at around 10 billion in the second half of the 21st century. Most of the growth is expected to take place in sub-Saharan Africa. Human population density varies widely around the world, but a majority live in Asia. By 2050, 68% of the world's human population is expected to be living in urban, rather than rural, areas. The Northern Hemisphere contains 68% of the world's land mass. Partly due to the predominance of land mass, 90% of humans live in the Northern Hemisphere. It is estimated that 1/8 of Earth's surface is suitable for humans to live on, 3/4 of Earth's surface is covered by oceans, leaving 1/4 as land. Half of that land area is desert, 14%, high mountains, 27%, or other unsuitable terrains. Humans have developed diverse societies and cultures. Politically, the world has about 206 sovereign states. States claim the planet's entire land surface, except for parts of Antarctica and a few other unclaimed areas. Earth has never had a planet-wide government, but the United Nations is the leading worldwide intergovernmental organization. Earth has resources that have been exploited by humans. Those termed non-renewable resources, such as fossil fuels, are only replenished over geological timescales. Large deposits of fossil fuels are obtained from Earth's crust, consisting of coal, petroleum, and natural gas. These deposits are used by humans both for energy production and as feedstock for chemical production. Mineral ore bodies have also been formed within the crust through a process of orogenesis, resulting from actions of magmatism, erosion, and plate tectonics. These metals and other elements are extracted by mining, a process which often brings environmental and health damage. Earth's biosphere produces many useful biological products for humans, including food, wood, pharmaceuticals, oxygen, and the recycling of organic waste. The land-based ecosystem depends upon topsoil and fresh water, and the oceanic ecosystem depends on dissolved nutrients washed down from the land. In 2019, 39 million square kilometers, 15 million square miles of Earth's land surface consisted of forest and woodlands. 12 million square kilometers, 4.6 million square miles was shrub and grassland. 40 million square kilometers, 15 million square miles, were used for animal feed production and grazing, and 11 million square kilometers, 4.2 million square miles, were cultivated as croplands. Of the 12-14% of ice-free land that is used for croplands, 2 percentage points were irrigated in 2015. Humans use building materials to construct shelters. Human activities have impacted Earth's environments. Through activities such as the burning of fossil fuels, humans have been increasing the amount of greenhouse gases in the atmosphere, altering Earth's energy budget and climate. It is estimated that global temperatures in the year 2020 were 1.2 degrees Celsius, 2.2 degrees Fahrenheit, warmer than the pre-industrial baseline. This increase in temperature, known as global warming, has contributed to the melting of glaciers, rising sea levels, increased risk of drought and wildfires, and migration of species to colder areas. The concept of planetary boundaries was introduced to quantify humanity's impact on Earth. Of the 9 identified boundaries, 5 have been crossed: biosphere integrity, climate change, chemical pollution, destruction of wild habitats, and the nitrogen cycle are thought to have passed the safe threshold. As of 2018, no country meets the basic needs of its population without transgressing planetary boundaries. It is though possible to provide all basic physical needs globally within sustainable levels of resource use. Thanks. We will meet with next topic.